Yes, welcome. 3 o'clock session in track number 8. So hopefully you're in the right spot. We're super excited to have Matthew McCaslin, who is a detection engineer for binary defense. He has over a decade worth of experience in information security. He specializes in designing detection mechanisms and is known for his expertise in various technical domains. Balancing professional pursuits with a passion for continuous learning. And today he's going to be talking about Alert Alchemy, correlating chaos into security gold. Matthew, it's all yours.
Thank you, sir. Everybody hear me okay? Yeah. All right. Well, welcome to Alert Alchemy. It's a clever title to draw you into sometimes I think considered a boring topic, so congratulations, I trapped you here. I appreciate y'all donating your time. I think I'm going to soapbox a bit today on some aspects of security operations that I think are potentially overlooked. They've been overlooked in a lot of scenarios I've been in, so hopefully I can share some stuff today that'll get y'all thinking and change how operations are working. I'm going to do a bit of audience interaction, so hopefully everybody can see okay. This is your warning to move up, though, if you can't. So there's some pictures and things that might be a little small if you're in the back. Okay. About me. I am a Houston native. I graduated from the University of Houston way back when, 2013, I think. I have a varied background in security. I think that's come to serve me fairly well. Starting out in more red teaming operations with web and mobile application security. I worked with the web application firewall, so very familiar with web concepts and web security. Moved into security monitoring, did some content management for that as well, trying to help build SIM content, and then now at Binary Defense, working with their detection engineers, trying to build solutions. Oh, and this picture's fun. This was actually, let me see if I go back. During COVID, I got my picture in the Astrodome, so it's my favorite to share. All right, just a quick agenda. That's what I'm supposed to show you guys, so if y'all get bored at any point or want to dip out and dip back in. Quick little introduction about some key takeaways and some stuff that I want to make sure gets across. And then we'll move into the different technologies. So some of the things we're going to look at today, I just kind of chose 3 popular SIM technologies to go through, show some examples, we'll get into it. Introduction. This is a picture I drew, by the way. If anyone needs any pixel art services, that's from me. Let's move in. So, any issue worth investigating, I think start with a problem statement, keep everybody on track, make sure we don't divert too much. And just to kind of get us in the mood, we'll imagine a scenario. You might have even heard the scenario this week at the conference, but imagine you're a new SOC analyst. You join a company, and you do your onboarding, they get you your credentials, you can log into all their tools, and they say, okay, now go defend us. There's no processes, or maybe there are processes that don't fit well, but when you go home at night, it's on you of, did you do good enough of looking into what they have going on to find the bad? And that's what led to this. Essentially, security operations centers struggle to detect real threats due to overwhelming alert volumes of debatable value. I don't think that's a surprise to anyone. If it is, come talk to me so I can see what you're using and see where the value is. But I think in general, we struggle with finding value in our alerts and our log sources. So that's what I'm going to try to talk about today. Talk about how security information and event management solutions and some of the functionalities they provide can help start to address those problems. So we know our problem. We have our problem statement. We want to figure out how to solve it. What is the first thing we should do? Search engine? We go to Google, all right? So we go to Google, we say, what's our solution to a large amount of security alerts? And the first thing we find is a Microsoft article. We all love Microsoft. They give us really good products, even if they're expensive. So we'll check out this link. 6 strategies to reduce cybersecurity alert fatigue. Man, that sounds like just what we want. Unfortunately for me, I don't know about y'all, but the solutions that they recommend here are a little bit high level. Threat intelligence is important. If you're that mature that you can start taking advantage of that, power to you. Native integration, I'm assuming that means they want you to buy Sentinel. Machine learning, you know, we start to get into some fancy stuff. UEBA, very cool. Automation, a lot of buzzwords. While they're applicable, I want to provide a solution that you guys can take and operationalize immediately. Not big buzzwords that we have to go try to invent a solution ourselves. So let's talk about correlation. So the main thing I wanted to make clear today, I'm not sharing any new ideas. Everything I'm going to be talking about is well documented online. There's a lot of really good resources, but I'm just kind of here to shout it again. And I wanted to make sure to give credit. So again, just go into Google, what's alert correlation, right? So back to Google, there's a paper from 1993 that I'm going to reference a couple times, alarm correlation. And this is a quote from the very first line of the paper. Modern telecommunication networks may produce thousands of alarms per day, making the task of real-time network surveillance and fault management difficult. Sounds familiar. Due to the large volume of alarms, network operators frequently overlook or misinterpret them. So this is 1993. We're not talking about alarms or alerts. We're just talking about network faults. And even then, we're having those issues. This quote here, I think, is good to take forward just what is correlation. And this is very high level, but a conceptual interpretation of multiple alarms such that new meanings are assigned to them. This is key too, because I think in investigating this, there's a lot of misinterpretation. You know, correlation is thrown around a lot. And so I'm going to try to keep to this as we go through the talk today. Something on that, just 2 words that I think kind of, you know, threw me for a loop, if you will. Aggregation versus correlation. I don't know if anyone can say what the difference between those is. But I put some definitions here to help. Aggregation, it says the formation of a number of things into a cluster. Very generic. I think that kind of fits with us too. Correlation is a measure of relationship between 2 measured data values. So that's a little bit more specific. We like that as well, but some of the examples I'm going to show, we kind of work outside of that definition. So I wanted to make that clear here. In that article, alarm correlation, they talk specifically about correlation types. So they even get more granular about the different ways that we can correlate network alarms. This one, it defines it again. Alarm correlation is a generic process that underlies different network management tasks. Some of these y'all might recognize. If anyone's been in Splunk, hopefully count is a familiar command. Compression is one that comes up and we're going to talk about later. That's really the main one that I'm going to address today, and I would encourage everyone to kind of maybe even look at some of these, the Boolean and generalization, maybe how that applies, because that's a bit more out of scope. But we'll look at how some of these come into play. All right, correlation. We understand what we need to do with our alarms to try to address them. Let's look at a tool. So Security Information and Event Management, or SIEM, again going back to Google, it says that this term first printed in 2005. I'm sure coined for some business purpose, but I have the NIST definition here. An application that provides the ability to gather security data from information system components and present that data as actionable information via a single interface. So that's a big term, but I think that's a really great definition because that's the goal. We're trying to get a single window where we can take a bunch of disparate log sources and start performing analysis on the data. Let's look at implementation. Okay, a bit of a warning here. This is kind of what led me to want to talk about this. Is I'm sure everyone's familiar with shiny object syndrome, but one trend that I tend to see is we have our SIEM deployed, it's ready to go. Now somebody brings up SOAR. and now we've shifted focus. My warning here is turn around. You've engineered too far. As valuable as a product SOAR is, the goal of this talk is to try to make sure we're focusing on those underlying systems, because if you shift too quickly, your SOAR implementation is going to be severely impacted, because a SIM is a big dependency, and I see a lot of times if the SIM is underdeployed, then it ends up that the SOAR platform ends up taking on the work that should be handled upstream. So this is a warning. As much as I'm sure you're all very familiar with SOAR products and think they're cool, be careful about putting too much emphasis on them before your SIMs feel good. So all that to say, the 2 goals for the talk. The first one, prioritize your SIM. Like I said, I think SIM tools are awesome and they have a lot of really great functionality, but I think I've seen too often where they're deployed, they have the out-of-box detections, they turn them all on, and then it's up to the SOC to deal with the output, and that shouldn't be the case. And then the second goal of this talk, again, I'm trying to do a lot of things here to try to make sure that I hit on something that people can take away. But the goal here is also to empower analysts. Want to show, as I go through setting up an environment and testing some of this stuff, show you some of the challenges that I faced, to try to embolden you to go out and do this stuff yourself. An early story I had working at the SOC was talking to a more senior member, and he was talking about writing a script that he would go home and run on his Palo Alto firewall. And I just remember being surprised, like, oh, I didn't even really think about running that at my house. Like, that's, if I want to test it, it has to be on the production version. And so this idea of taking these production tools that we use at work and then spinning up a lab at home to be able to do stuff on your own, I think is a really powerful tool that more analysts should be able to take advantage of. All right, let's get into it. Let's get to work. So ELK is what we're going to look at first. And I realize I haven't defined that yet. We'll get there. But the first thing we need is a lab environment. Like I mentioned, we want to be able to test these things out. We don't want to just write rules and hope they work. We want to make sure they actually do. We have a few options to kind of make it easy for us. I've got DIY up there. Good luck if that is your choice. I think there's a lot of opportunities for learning there, but there's a lot of overhead. You're going to learn a lot about an infrastructure and a domain before you start to get into security and SIMs. So power to you there. Some other links I've provided here to some open source tooling that I think has been beneficial for me. Detection Lab mentioned there was one of the early examples I've seen of a Windows domain. And that one is Vagrant VMs, a really good tool. And then the one that we're going to talk about, or I'm going to use for the talk today, is the third one there, the Marvel Lab project. I chose that one just because it's the easiest of the 3. Very convenient and relevant. But like I said, I'll leave it to y'all to decide what's best for your use case. So the project itself was created by Jonathan Johnson and Ben Schell. On their GitHub, it mentions it's a collection of scripts to help automate the build process for a Marvel domain. Marvel domain is a Windows domain, but it's Marvel themed, so that's kind of fun. The lab is meant to be used for research and detection development, so it's specific for our purpose. And it's very feature-rich. Even today, I'm not going to be taking advantage of all the features. One of the parts that's really nice is it spins up a Windows domain, and I end up really just utilizing a single endpoint, but especially if domain activity is what you're going for, this makes that really easy. Marvel Lab also comes with some of the tools that I'm going to show today. And one I want to mention that I don't actually take advantage of is Zeek. It has a Zeek deployment. If you're interested more about that, I'm not going to go into Zeek in this talk, but one of my colleagues, Ross Burke, spoke before this. He goes into detail about Zeek and its usage, so if you are interested more in that, that's a good talk to check out as well. We're going to be taking advantage of the applications that come as part of the pre-built logging configurations. So I know I don't like to mess with logging configurations. I know a lot can go wrong with that. So Marvel Lab is very kind to do a lot of that for us. So the first thing we need is some VMs. We run into our first issue. Has anyone ever seen this one, built a VM? This one gave me some trouble. So we have an error. We go to Google, right? We Google in, what do we Google in? Whatever that said, software license terms. And we get all these answers. You know, this is part of the testing process. Nothing's going to work right the first time. So we can go through, we read some of those, dynamic memory. I don't think I had that enabled. I had plenty of memory. Oh, the third bullet. Your virtual machine has a floppy drive. Yeah, Windows 10 really doesn't like floppy drives and will possibly fail. Oh, that's weird. Let's try to turn off our floppy drive. Yay! We did it. We fixed the problem. That was a bummer. Like I said, an example of taking a problem and not letting it get in your way, I guess. So that's the first example. We'll see some more. But VMs have always been an issue. Luckily, for me, Windows was really the only trouble. The Ubuntu logging machine that we are about to utilize and the Windows desktop weren't a problem. This was only Windows Server that ended up with the weird floppy drive error. But, you know, in your process, you might run into this as well. So, we got our servers up, 3 servers that Marvel Lab asked us to deploy. I didn't want to go too much into that deployment. All the docs are really good, linked here. This was a struggle, just like, you know, if VMs are hard, applications are more complex, right? The command down at the bottom, the Docker. If you've ever worked with Docker, I'm sure you're familiar with this, but I was using that a lot, where it's if something's broken, just get me inside the Docker so that I can fix this stuff. But as much as that was a problem, it also saved us a lot of time, in deployment. One of the things I wanted to mention here is snapshots. I know a lot of folks might overlook them, especially if you're not using the professional version of VMware, but I can say from experience, reverting to snapshots was a frequent occurrence, especially when you're building a big project like this. It was nice to be able to just say, let's go back. I'd say I reverted at least 15 times throughout doing this, and I can't imagine how much more challenging it would be otherwise. Okay, we got some applications, so let's actually start doing stuff. We're talking too much about deploying. Oh, we got another error. We're missing a piece. This one seems a little bit different. At least we're in a command shell now, instead of a Windows installation prompt. Anyone see the error? It's my audience interaction. It's the red stuff at the bottom. So this one, it's giving us an error that we can't find inputs.conf. If we're familiar with Splunk, we understand what that's related to, but again, this is a place where we could hit this error and just stop. We could say, oh gosh, I have no idea what's happening with Docker. I don't know what even this path is. I guess I'm not smart enough to do this. But the encouragement is go in and look, you know. Don't just depend on the project. Understand that there are scripts being run behind the scenes, so we can go in and see, okay, this file that it's expecting isn't there. It seems simple enough, but even in this deployment, this is an error where we can submit back to the project owners and say, hey, your automation is looking for something that isn't there. We can go in and manually stand it up, and that gets us through the problem. And we'll actually be coming back to this because we're not even there yet. We're still talking about Elk, and this is a Splunk error. So let's get back to Elk. So let's define it. It's Elastic, Kibana, and Logstash, known as the Elastic Stack. This is really nice, free. You like free stuff. I would say this is the most accessible option of the different SIMs that we're going to look at, mainly because it's free. but also has a lot of capabilities to get started fast. And even of the deployment options, this was the one that seemed to deploy the easiest. I will say it's probably the more complicated once it is deployed, so I'm lucky that Marvel Lab did all that for me, and I didn't have to actually go in and fix anything. So as we deploy it, again, trying to show some of the issues, I want to talk a little bit about what happened after I did deploy it. So we have a Docker container here, and we see, I'll kind of come over to the screen, where are they at? Different ports on this side. So we can see different stuff that's been spun up, but the documentation or the scripts don't actually tell us what to do with it. On some of the other installations we'll talk about later, it actually gives us a link to go to. But here, we're stuck again. It may not actually look like an error, but our setup scripts are done. We don't know where to go. This part was kind of fun for me, just in working with CTS, because it almost felt similar. Where now I've got open ports and I need to go look at them to see what's there. Kind of playing around, Googling again. I finally figure out that, and again, if you're familiar with Elastic, you probably know this answer, but 5601 is the application port. So going to my server on 5601, I'm presented with a login screen. Fantastic. But I never set up credentials. So how do I get in? Again, this is the CTF part. Luckily, going to Google, I find that the default username for Elastic is Elastic. Surprise, surprise. And the password just happened to be a password that I set up previously in the configuration. So we got through. We made it in to Elastic, if you will. But what do we do now? Let's look at a visualization. So we can see on the left, sorry, let me back up a little bit. I wanted to talk about how we got logs into Elk. There's a little bit of a challenge, but essentially it's just a basic service that runs on the endpoint. So once that service is installed, we start seeing Windows events come through. So that's what you can see down on the bottom, some of those events. I think, I meant to put a reference in here, but there's some really good documentation on Elk, on getting that agent installed. And I'll say, we'll see later that it doesn't go as well for the other SIMs. But luckily we got this one in, we're getting data, and we want to start honing it down. I don't think this shows, oh it does. You can see at the top there, we have 789,000 logs. So that's kind of what we're starting with, and that's our goal, to try to correlate, if you will. All right. In Elk, it's this visualize button, very handy. We can click on the left-hand side. It shows us some popular events, or fields, I should say. We like event code. We can see over there, whenever we click on it, it highlights and it shows us some of the event codes that are coming back. Some of y'all are familiar with Sysmon, might recognize some of those. Some of the ones we're going to focus on, event ID, oh, you don't even see it there. Event ID 11, we'll come to that in a second, I apologize. Let's filter by users first. So if we click on the user field here, apologize, this is what we're correlating on. So we're telling Elk, show us all of these fields and do a count of the records. So that shows us all these here. Network and local service, these are familiar things. Systems, fairly familiar. And then here we can see a couple users that might be unknown. This is a way to kind of filter down, right? We're already not dealing with 800,000 logs anymore. We're dealing with 5. So we'll pick one, and I'll admit it's a bit shoehorned, but let's look at this Alchemist user. And this is the event IDs I was trying to speak of, where we find some interesting ones. Even down at the bottom of the count there, usually rare event IDs are interesting. We can see event ID 11 is a file creation log. Event ID 3 is a network connection. Some interesting stuff if we're trying to drill down and get some more information on what's going on. So let's look at some of those. So I should mention here, let me come back. At the top, this is the query string in Elastic. So as I'm making queries, that's what I'm modifying. If I wanted to say, look at this other user, it's just a simple replacement in the top, obviously. So same up there, we just add an and. We add our event code, the file creates we're interested in. Narrow it down a little bit more by certain file name. In this case, we're looking in the user's downloads folder. And we can see an interesting file download. Don't worry about that executable, right? But we've narrowed it down. We can look at network connections. This as well is interesting. If we look at the bottom there, PowerShell's making some network connections. We can see at the top, Microsoft Edge might be a little bit more normal, a user going to the internet. But PowerShell stuff shows us something interesting that we can drill down into further. So some interesting events, but still pretty basic. Say, Matthew, that's really not anything interesting. We can make those. Okay, let's look at another sim. Let's go to Sentinel. This one's going to be a little bit more challenging. I put some references there if you're a Microsoft customer and really want to get into it. They've got some recommendations on how to set up a lab within their environment. But I don't like to spend money, so we're not going to do that. And unfortunately, Marvel Lab also can't help us. Its pre-built logging environments don't include Sentinel. So we have to get a little bit creative. So this is a tool that I found working with Sentinel. Again, folks might be familiar with, but it's a demo environment that Microsoft provides. It's just a simple link, and you get in there and you can start playing around with data. There's definitely some pros to this. Obviously, it's really fast. You can get in there straight away. You don't have to build your own data. You don't have to build your own environment. Of course, with that pro comes the lack of control. You lose the ability to pipe your own logs, run your own tests, do your own stuff. But it can be beneficial in the right hands. We do need a Microsoft account, so they did get me there. I can't be completely anonymous, but at least I can get in there for free. So this is what that demo environment looks like. Pretty straightforward. In the screenshot, you can see I'm just filtering on the security events that they provide. Running a bare search like this is always good in a new environment with new logs, so you can get an idea of the different field names returned and what kind of data you can play around with. But let's dig into that a little bit in more detail. So we've got the events. The summarize command in Sentinel is kind of like our correlator, if you will. And it'll let us perform that count functionality. And now we can start to see, okay, we've got Windows events. Let's see the different IDs. And not only that, we can see the description. So it lets us really quickly and easily see, okay, what kind of stuff might we be interested in. This one won't be as interesting security-wise, just because, like I said, we don't have control over the logs, so we kind of got to play with what they give us. You know, we might want to look for something similar to what we did in the first example. Maybe file creation, network activity, try to correlate those two things together. Unfortunately, we don't have those kind of logs, let alone sysmon. So we'll work with the Windows events we have and try to give a good example of what we can do in Sentinel. So here's kind of a crazy query, and I'll caveat to say that there are a lot of KQL queries online that can be found. This is a very trivial example just to kind of show what you can do. But what this is essentially trying to do is correlating between logon events and logon failures. So if we look at these two event types, You can see I'm filtering. There's a couple where the 4624s. Those are, what is that, logon success, and the 4625 is the failure. I'm getting that right. Of the successes, and again, I'm not showing this data here, but there were 4 million logs for the past hour. So if that was something we were trying to monitor, there's no way, right? Even if we look at the failures, which is a common alert type in Security Operations Center, 4,000 logs for the past hour. That by itself as well, we can't really do much with. With correlation, what we can say here is let's only alert on successes where there's a previous fail count of more than 10. You can see that in this line here. This join lets us join those two tables together, and then we end up with, I wish it would show on the screenshot, a very much smaller amount of alerts, if you will. So that cuts it down. Like I said, there's a lot better ways of doing this, but this kind of shows how quickly we can get in and just start writing queries, start testing queries. All right, back to familiar territory. Splunk. They've also got some documentation on setting up a lab environment, which is fine if that's what you'd like to do, but thankfully for us, Marvel Lab actually supports a deployment for Splunk, so we're going to stick with that, give ourselves full control. Let's keep going. We want to get data in this lab environment, again, spun up with Marvel, and Splunk provides a few different ways of doing that. They do have tutorial data, Buttercup games. I'm sure if you've messed with Splunk, you're familiar with that. And then they also provide the internal index, which is something that comes essentially as a default index with Splunk. While those are logs, we want to do something a little bit more interesting, play with more interesting data. So let's, similar to Elk, let's try to create our own. So once we have this deployed, in the same way as Elastic, if we go to the endpoint, we kind of start playing around making logs, we come back to our Splunk instance, and we don't see anything. We're stuck, right? So back to Google, we're troubleshooting. One of the recommendations from Splunk is this internal index that I referenced earlier. We can say, let's look at the errors. And unfortunately for us, we can see here, we're getting like some certificate failures. Uh-oh. If you've messed with certificates before, they're terrible. I tried to fix this for a long period of time. And spoiler alert, I did not. So that's continuing work for me to do. But we still have a talk to do. I did think this was kind of funny. As going through trying to troubleshoot the certificate, and Splunk's documentation is really great. But I really liked, what is the second line? You must combine the files in the right order, and the combined file must be in the correct format. If you don't combine them correctly, your Splunk platform instance won't be able to use it. It's just like, okay, very, very specific. And yeah, no matter what I could do, could not get that data through. But luckily there's some, again, we'll fall back to some open source projects. These are both data sources for Splunk that can be uploaded, and then you can play around with it. Very similar to what we did with Sentinel. But this time we do get a little bit more control. Like I said, we've got, I won't actually use it in this talk, unfortunately, but the attack data GitHub, if you're looking for specific attacks to play around with, and then the boss of the SOC data is what we're going to look at today. But very nice of them. This was very welcome to somebody who was struggling with getting their lab set up. So we have data, same as with Sentinel. Let's find our data source. The bots data has a bunch of different data types. And for this, we want something that's a bit meatier. Once we dig in, this is a pan index data that we end up looking at. And we can see a few different source IPs that we see hitting our firewall. The second line, count by source, that's what we're seeing here in the count. So still a lot of logs, But you can see us, we're cutting it down. We're still starting with close to 800,000, but this statistics has got us down to 500. Even still, we're closing in on a more manageable amount of data. And we can even further cut this down. If anyone notices something in those IP addresses, they're not something we're really interested in this use case. Those are internal RFC 1918 addresses, so let's filter those out. So we add in just one more line. Splunk has this nice CIDR match functionality where we can just cut all that out. Now we've got some interesting stuff. First one, IPv6, I don't really even know what to do with that, but at least we have some external IP addresses that we can start looking up and validating are those IPs that we do expect to be hitting our firewall. So firewall data is not very fun. Let's be a little bit more interesting with it. You can see we have the same search essentially, but we've got some fancier stuff in there. That third line there is a bucket command within Splunk. Lets us put all the data in these 1-hour buckets, and then we can perform some statistical calculations on that data. The average, it's going to take the average count of each of those IP addresses, and then at the end, it's going to save it in like a new document, if you will. So if you're familiar with the output lookup, that CSV is something that then we can come back and reference later and say, okay, this IP is hitting us, but depending on how long we want to store the average data for, we can go back and check and see, is this expected or not? So a bit more fancy if you've got the resources to store, and obviously like I said, this example, I'm just doing a day search to store that statistical information, but you could bump that up to as much as you like. Probably a week might be better. All right, picture of a cat, we made it. The labs have set up. We've done some correlating. Here's something to look at while I talk about what we did. We used some data sources within some various SIMs to cut down our log sources and hone in on the data we care about. Some of the data we looked at was a bit simple, but hopefully it gives you an idea of where you can start. This information, you can work on EDR logs, antivirus logs. You can start doing really interesting stuff with risk scoring. So this is a really good foundation that you can build on. Final tips. Correlation can help you manage large alert volumes when it's properly deployed. A lot of these SIMs have out-of-the-box solutions for this, but it's going to likely require a human to manually come in and configure to get that stuff right. Ensure you're using your SIM to its full potential before you move on to newer and shinier projects, looking at use SOAR and AI. And like I said, the process for you and your production environment will likely be different than what I've shown here. A lot of this has been very simple just to kind of show you what you can do on your own. Very thankful to these projects. Like I said, wouldn't have been possible without it, and definitely enables all of you to go out and do all of this yourself as well, which I think is fantastic. And then I'm big on additional resources, recommendations, stuff that you guys can go out and do on your own. That first presentation in the list there, Supercharger Risk-Based Alerting by Teresa Chilla. Once you've gotten correlation down pat and you're ready to start implementing better logic on top of that, that talk is great. Most of what I've talked about today, you can find in more depth in the HTB Academy courses, fantastic courses, well worth the money, definitely recommend. And then a couple of YouTube channels of some creators there that I think are really great about getting in and doing stuff yourself, getting hands-on, which I think is really, really important. And I think that's all I have to say today. Thank you. It looks bad. Yeah, you end up in the same place where you have a lot of stuff of low value. So, yeah, there you go. Exactly. I mean, that's what it's like. All the data sources are alike. At the end of the day, it's about what you do with them and how you handle it. So strongly recommend, that's where SIM is nice, because it doesn't matter what the data source is, it can ingest it and then you can do some analysis on it. But I think in practice, it can be a challenge to get everything lined up.